All right, everyone, we are starting a new chapter on polymers and plastics. So we're going to learn in this chapter how plastics and other polymers are made and then their effect on the environment. So the name polymer just means it's a long chain of smaller repeating units. The repeating units are called monomers. So the prefix poly, as you know, means many, and mono means one. So we have two types of polymers that you will see. Natural polymers are just polymers that are already found in nature, composed of monomers that are also found in nature. So cellulose is a polymer of sugar, starch, another polymer of sugar. DNA is a polymer of what we call nucleic acids. Wool, cotton, skin, natural rubber, they're all polymers of something, but they're all naturally occurring. Synthetic polymers are polymers that we actually make, so plastics will go into this category of synthetic polymers. This picture here actually shows the major types of plastics that we use. So there's 7 of them here. They all have their own abbreviation. We'll discuss some of this, not all of them. They're found in all kinds of products, as you can see here, from plastic bottles all the way to your hangers, even garbage cans, food container, and so on, and building materials. So it really has a wide use, and more importantly, what we want to know is how can we recycle or dispose of these plastics when we no longer use them in a way that will be healthy for the environment. But let's first talk about how these polymers are made. So the idea of monomers and polymers is fairly straightforward. So a monomer is just a single unit. A polymer is when you combine them together, right? So for example, you can have a bead like this, and then when you make into a bracelet with a collection of beads, that would be your polymer. This is a single Christmas light bulb, and then when you connect them together, it becomes your chain of Christmas lights. This is actually a really good illustration because many molecules look like this as well. So those black wires that connect this Christmas light, you can imagine them to be your chemical bonds that connect the different monomers together. The polymer that we use quite a bit is something called polyethylene, or PE. This is a type of synthetic polymer that is made up by the monomer ethylene or ethene. Now you might remember ethene from our discussion of hydrocarbons, which are compounds containing only carbon and hydrogen. We talked a bit more about alkanes in that chapter, but we also discuss alkene briefly, and alkenes is just hydrocarbons that contain one or more carbon-carbon double bonds. So in alkane, you only have carbon-carbon single bonds. So polyethylene is a polymer of ethene, which looks like this. It's just a 2-carbon compound where there is a carbon-carbon double bond. And so how you make polyethylene is you combine a number of these ethene molecules or ethylene molecules into a bunch of them. So for example, here is showing how that works. So you have 2 ethylene molecules, you add them together through a chemical reaction, and now you have this polyethylene molecule that has 2 monomer of ethylene in it. A lot of times, instead of writing a bunch of these guys together, we would just write it with this brackets with an N next to it. That tells you how many ethylene units or ethylene molecules are originally existing to make this new polymer. So for example, in that one, we can write it as this with a 2 next to it. That will tell you that it has 2 monomers. These things tend to get quite large because you can, polymerize this many times. And so the molar mass typically goes to 10,000 to 100,000 grams per mole. At those sizes, we don't use the unit grams per mole anymore. We usually use the units Dalton, DA. And because they're so large, we use the prefix kilo to attach to the Dalton, so it would be written as KDA or kilodalton. So if you have something like a 10,000 molar mass polymer, you would just call it 10 kilodalton polymer. And again, that could go all the way to 1,000 kilodalton, which of course is like 1,000,000 grams per mole, so it's really large. This is a question if you can figure out how many monomers exist here in this particular polymer of ethylene. Remember that each ethylene is 2 carbons, so you just have to divide this by 2. So 1, 2, 3, 4, 5, 6. So there's 6 divided by 2 is 3. So there's 3 ethylene units here. Okay, now that we understand, at least in a simple way, how these plastics are made, we can take a look at the most common types of plastics that we use. them. We're only going to discuss 5 of them here, and this is really going to be a really cursory look into these plastics. So polyethylene we had discussed just now, and there's 2 types. There's the low density and the high density polyethylene, and this table here shows the different densities of both natural polymer like rubber as well as a number of these other synthetic polymers. And the low density polyethylene is here and the higher density is here, and you can see that there's not a whole lot of difference between the two, but in terms of application it's actually quite different. So the low density is the one you typically use for those soft plastic bags that are pretty stretchy, so you might have them as garbage bags or sometimes as plastic bags in grocery stores. In California, they used to use that. Nowadays, they give you the more rigid plastics that are a lot harder to stretch, and sometimes those are made from the higher density polyethylene. Now, stiff plastic bags as well as toys are also made of those high density polyethylene. So it's quite different. Even though the numbers don't look that different between these two, the actual difference in the material is sizable when you go from the low density to higher density polyethylene. And you can see in this picture here how the monomer looks like. So it's showing you that both polyethylene, the low density and the high density, is a unit of ethylene where that double bond has been converted to a single bond. Another common one that you might have heard before is PVC or polyvinyl chloride. You might have heard it in the context of PVC tubes that people use for house siding, for piping in the house for water and other purposes. Furniture, auto parts. This is made up of this unit where there is a chloride sticking out. So it's fairly similar, as you can see, to the polyethylene, except that instead of a hydrogen, one of the hydrogen is replaced with a chlorine, and that makes that material a lot stiffer as a result compared to polyethylene. You can see here in the density, so if you look down here, the density of polyvinyl chloride is 1.38, which is pretty high. Even the high density polyethylene is quite a bit stiffer than the low density one. So if the density is now 1.38, you can imagine how much harder the material is, how much stiffer it is. And in terms of application, it could be used for water flow and so on. And you want to replace it with this because some of those pipings that used lead as the material to make the pipes, we know that lead can leach off and then be dangerous and toxic, as we discussed before. So some of these plastics that are used prevent that from happening. So polypropylene is another type of plastics called PP. Might not have been something you heard too much about, but this is one where it's incorporated into textiles, for example, in carpets. So if you have rugs, instead of just pure fabric, there's actually some plastics, synthetic plastics, that's incorporated in it to make those carpets. Looking at the molecular structure here, again, not that much different than the basic polyethylene building block, except that, again, that hydrogen that was swapped earlier for chlorine in PVC is now being replaced as carbon in polypropylene. So very, very similar structure, as you can see, between these 3 things that we've discussed so far, PE, PVC, and polypropylene. They all just have the same basic structure, except that one of the hydrogen is replaced either with a chlorine or with a carbon. Now, polystyrene, you might not have heard of polystyrene itself or PS, but you might have heard of styrofoam. So that's materials we use in these packaging of food packaging primarily. If you've interacted with styrofoam, you know it's a little soft. So it's particularly good as insulation materials. It's used a lot in electronics housing and casing to prevent contamination of electrons from other things coming in. Again, looking at the molecular structure, very similar, except that that same hydrogen that's been replaced earlier with chlorine and carbon in the other 2 types of plastics, now it's replaced by this whole ring here, which is called a benzene ring. Same building block in terms of the basic skeletal structure of polyethylene, but then replacing that hydrogen with a different type of chemical entity. And the last one we're going to talk about is polyethylene tetraphthalate, or PET or PET. And this is used in textiles and packaging. Almost all of your soda bottles, regular beverages, use PET as the plastic that's being used. So you know how stiff some of those bottles are, right? A lot of times it's a mixture of plastics, that's being made to actually create that specific material. But the major component in those bottles are the PET plastics.